Здравствуйте, мои дорогие русские YouTube-зрители! Сегодня я покажу вам, как я строю и измеряю маленькую плату усилителя с 3 транзисторами. Я думаю, что вы тоже будете понимать мое видео на английском языке. Hi again, now in English. Today I will show you a little transistorized amplifier. The main purpose of this circuit is for learning how an amplifier from transistors working. Here you can see the web page. Its item number is 12492. At the moment it is not available, but it will be available soon, and its title is OTL Power Amplifier Circuit Do-It-Yourself Kit Module Electronic Practice Kit Learning Suite. So here you can see the component side of the board. The components are very far from each other, so it is very easy to build this circuit. Let's see the other pictures. That is the bottom side of the board. Unfortunately, it is poor copper. I don't like it so much, but I will apply some flux, and here you can see the components, and here you can see the ready-made circuit. We have some jumpers to modify the operation of this circuit, but let's see the connection diagram. Here you can see the connection diagram. Let's make it bigger. Here you can see this circuit contains 3 transistors. The 2 at the output are a complementary pair, and 1 NPN transistor at the beginning. So this Q1 is a grounded or common emitter circuit. That is the base voltage divider at the beginning. With RP1 you can set the working point of this transistor. Because here is a DC voltage, that's why there is a DC isolation C1, and at the collector circuit of Q1 you found a small circuit based on a diode. It produces about 0.6 volt voltage, and with this RP2 trim pot you can increase this voltage to minimize the cross distortion of the output. So the 2 transistors will be nearly opened, and therefore if it is if this collector is moving, then the bases are moving together but on different voltages, and therefore the output will be less distorted. And you can use a jumper here, and if you apply a jumper here, then C3 will AC blocking this negative feedback at the emitter circuit, so the amplification will be higher. Here you can also use a jumper to modify the working point, and with S2 you can do the same. After the building we will see how they affect the output signal or the amplification ratio or the shape of the signal. So let's see the components. On the web page you can find the component list. Be careful because all the 3 transistors are different type, and we have resistors. Each resistor is 1 except R5, but RL, which means load resistance, I don't know, is it in the bag or not? We will see it. We have 2 trim pots, but they are different form factors, so you cannot mix them, and that's all. Let's see what are in the bag. Some codes. It was packed in April. This is the PCB itself. Here you can see the PCB. We have some header pins for connections. 1, 2, 3 jumpers, 3 transistors, the 2 different trim pot, 4 electrolytic capacitors, 1 diode, and yes, we have 2 100 ohm, one is for load. Okay, let's assemble the circuit. Now the circuit is ready, but it hasn't any user interface, so the only way to check this circuit is the measuring. Okay, let's measure the circuit. This circuit is 11 gram. Okay, that was only a joke, sorry. So of course we need electrical measurements. I applied some color pins to make more easier for you to follow what's happened. So the black is always the ground, red is the power, VCC, yellow is the input and the output, and this white is a measuring point, and here you can see the jumper positions. Now I try to show you a minimal system. You need a small oscilloscope, a small signal source generator, here you can see, and a power source. So I like this power source because it has a USB for my oscilloscope. I apply a 9-volt up converter for this small oscilloscope, and it has 3 connector pairs for 5 volt and 3 connector pairs for 3.3 volts, so it is very useful if you apply more than one board. So this is the ground, this is the power, the ground of the generator connected to the ground of the amplifier, and now everything is connected. Let's turn it on. Here you can see the output signal. The output signal is not the best. Let's try to set it. Maybe it is now much better. So the problem was this cheap oscilloscope that we cannot compare the input and output signal phase, because we can see either the input or the output, but never both together. So after showed you this minimal configuration, I will apply some more serious devices to make more precise measurements. But for example with this, let's check if I connect S3, then the amplification, or will be much higher. So let's see. I decrease the input level. So that is the amplification. We can measure the input signal, of course. Here it's a little noisy, but it's in 10 millivolts division. 1, 2, 3, 4. About 40 millivolts peak to peak. And let's see. And now the output is 1, 2, 3, 4, more than 5. It's about 1 volt peak to peak. So it is about 25 amplification. Now let's remove this. And now it is only 400 millivolts. So now we apply a feedback. And let's see S2 effect. Nothing interesting. And S1. If we apply both S1 and S2, then the output will be short-circuited by EC with C2. If you apply R5, then it not 0, but so. And apply all the jumpers to see what's happened. Oh, it is a very distorted signal. Okay, so let's continue this measurement with real measuring devices. Now I assembled the measurement with some more serious devices. I choose this oscilloscope because it has an anti-glare screen, so not works like a mirror, and this Rigo generator, I very like it. So let's see now. The yellow is the input signal and the purple is the output signal. Now you can see that it is in the opposite phase, and of course it is so because here you can see these two complementary transistors works like an emitter follower, so they don't change the phase, and this first transistor here works as a common emitter amplifier, and it means between the base and the collector there is a 180 degrees phase offset, and because it is followed by these two transistors as a follower, the final result will be the opposite phase at the output. So now the jumper S3 is on, so the amplification is high. Let's see what is the maximum level. If I increase, you can see that the output signal is distorted. So let's suppose now it's nearly a sine wave, maybe a little not. Oh, it seems better. So now the input signal is 60 millivolts peak to peak. Let's measure it with the oscilloscope also. So let's calculate the amplification. The input is 60 millivolts and the output is 1080. And it is, the amplification is 30. Now let's remove the jumper. It's much less now. Now it is 280 millivolts divided by 60. That is 4 2/3. And now, of course, I can apply much more input signal. Now, without S3 jumper, for example, the input is 240 millivolts and the output is 1060 millivolts. Let's calculate the amplification. Now it is 4.4, so nearly the same. And let's see what's happened if I increase the frequency. Now it is 1 kilohertz. It is a very commonly used frequency on any audio circuit, and suppose that is an audio amplifier. And now set it to 2 kilohertz, 2 kilohertz, 3, 4, 5. 10 kilohertz, 15, 50 kilohertz, 100 kilohertz, 2, 3, 4, 5, 6, 100. Now it is distorted a little, but the amplitude is nearly the same. 1 megahertz is too much. Maybe we can try to modify the working point. Oh, it is able to amplify nearly up to 1 megahertz. Okay, let's go down. 100 hertz, 50 hertz, 20 hertz. So it is a good hi-fi amplifier, for example, as a frequency response. Maybe the distortion is not so good as a hi-fi amplifier is required. So I'm saying that was enough from this very small circuit. Maybe it can produce a small volume sound in a speaker. It's hearable. Normal A sound. So for example, you can use it as a headphone amplifier because the headphone impedance is usually higher, and then if you apply it on your head, lower volume is also enjoyable. So I'm saying that was enough from this very small and easy circuit. If you want to make similar experiments in your own place, don't forget you can buy it on ICStation.com, just not now but a little later. And don't forget the discount code which is mentioned in the description. If you apply it at the end of the purchase, you will get 15% discount. And if you found this video useful and if you liked it, please thumbs up. Don't forget to press the like icon and subscribe to my channel if you haven't done it yet, and if you want to see my future videos mostly about electronics and do-it-yourself kits or measuring techniques or a lot of interesting things. Thank you for your watching. Have a nice day and goodbye.